Trigonometry, Chapter 3, Radian Measure in the Unit Circle, Section 2, Applications of Radian Measure, Video 5, Area of a Sector. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we learned how to use the arc length formula to explore the relationship between the rotation of a pulley and the length a rope or chain is raised or lowered. In this video, we will learn how to find the area of a sector. Botched copy and paste job, but that's okay. A sector is a portion of a circle cut off by a central angle, like in this picture. Now, technically, a central angle cuts a circle into two sectors, one with an angle less than or equal to 180 degrees, and one with an angle greater than or equal to 180 degrees. But unless specified otherwise, we assume we are talking about the angle less than or equal to 180 degrees. Actually, use whatever angle they give you. So if they give you a 240-degree angle, use it. But how do we calculate the area of this sector? In a word, proportions. The area of the sector, this pizza slice, is a fractional part of the area of the whole circle. That fraction is the same as the ratio of the central angle to an angle associated with the complete revolution, which is 2 pi radians. And we are going to be doing this in radians. If it were in degrees, we would say 360 degrees. So the proportion is going to be area of a sector compared to the area of the circle is equal to the central angle of the sector divided by 2 pi. We'll replace area of a circle with pi r squared because it is, central angle of a sector with theta, and for convenience, area of a sector with capital A for area, like this. This is pretty easy to solve for A. We just have to multiply both sides of the equation by pi r squared to look like this. And how would this simplify? Well, the pi's would cancel, and then we could write it a little more cleanly like this. Area equals 1/2 theta r squared. Some books say area equals 1/2 r squared theta. It's a multiplication problem. Either way is good. This is the formula for the area of a sector cut off by a central angle of theta in a circle of radius r. Remember, theta must be in radians. It has to be in radians for this formula because we assumed radians with the 2 pi. If we assumed degrees, we would have put a 360 there with where the 2 pi is and gotten a different looking formula. So this formula assumes that we're in radians. For example, an irrigation system includes a powerful sprinkler that goes back and forth and waters a circular sector shape of land. If the angle of rotation of the sprinkler is 15 degrees and the maximum distance sprayed is 321 meters, that's a powerful sprinkler. Find the area sprayed, round to the nearest meter. Well, this is clearly the area of a sector. But first, we convert the angle to radians. We could embed this in the calculation of the area, but multiplying 15 degrees by pi over 180 degrees and reducing to pi over 12 does not round and does not lose any accuracy. So we'll go with that. Now we'll calculate the area with theta equals pi over 12 and r equals 321 meters. Simply substitute the values into the area formula. We have area equals 1/2 pi over 12 times 321 meters squared. And then we just get out a calculator and approximate that the area is about 13,488 square meters. That wasn't bad. That was pretty straightforward. Now you try. Pause the video and try the following. Number 1, find the area of a sector cut off by a 45-degree central angle in a circle of radius 12 inches. Write your answer as a multiple of pi. Number 2, if a circle has a radius of 24 centimeters and a central angle cuts off a sector of area 192 pi square centimeters, find the central angle in degrees. So a backwards question, if you will. Pause the video, give it a try. All right, here's your fair warning if you haven't paused the video to try the problems yet. Solutions in 3, 2, and 1. Don't forget the last one, ask for the angle in degrees. the equation, the formula gives you the answer in radians, so a conversion is necessary.